Welcome to the deep dive. Today, we're really zeroing in on mechanical engineering job interviews, specifically for freshers.
Yeah, looking at those common questions, and what makes a good answer actually sound good.
Exactly. We've got a bunch of typical questions and suggested answers here. And the idea is to get past just memorizing things. We want you to really get the core concepts.
Right. It's like a shortcut to feeling genuinely clued in on those fundamental principles.
So whether you're prepping for that first interview, or maybe just want a quick refresher on your ME basics, or hey, even if you're just curious about the field, this should be helpful.
Definitely. So let's dive in. That classic first question. Tell me about yourself. What are interviewers really looking for from a mechanical engineering grad?
Okay, yeah. Beyond just name and uni, what's the important stuff to hit?
Well, for a fresher, it's really about signaling you understand the fundamentals. Mentioning subjects you like, say, thermodynamics or mechanics, shows you've got that base. And definitely bring in project experience. Even small student projects count. It proves you can, apply the theory.
Right, shows you've done something hands-on.
Exactly. And software skills, AutoCAD, SolidWorks. Maybe mentioning you've touched MATLAB or aspire to learn ANSYS. That's a big plus.
So it's like a highlights reel: fundamentals, projects, software, and enthusiasm.
Yes, that eagerness to learn and actually contribute. That really comes across. It's your potential in a nutshell.
Makes perfect sense. Okay, another big one. Why mechanical engineering? What's a good, genuine answer there?
Honestly, a really strong starting point is just curiosity. Saying you're fascinated by how machines work.
Seems simple, but effective.
Very. It shows an inherent interest, a sort of natural drive to figure things out mechanically. That's the spark, really. Employers love to see that genuine curiosity.
Okay, got it. So that innate interest is key. Now let's get into some core principles. Thermodynamics. Those 4 laws, they sound intimidating. Can we break them down quickly?
Sure, let's try. The 0th law is basically about thermal equilibrium. Things in contact end up at the same temperature. Sets the stage.
Right, temperature basics.
Then the 1st law, that's energy conservation. Can't create it, can't destroy it, just change its form. Like heat into work.
Okay, energy's constant.
2nd law introduces entropy. Basically, things tend towards disorder naturally. Heat flows hot to cold, not the other way around spontaneously. It gives direction to processes.
The why things happen a lot, sort of?
Kinda, yeah. And finally, the 3rd law says as you approach absolute 0 temperature, molecular motion pretty much grinds to a halt. Can't quite reach it, but you get incredibly close.
Wow, okay. So temperature, energy conservation, disorder, and absolute 0 limits. That's a neat summary.
These underpin everything in mechanical systems, really.
Okay, next pair. Stress versus strain. Often confused. What's the clear difference?
Think about stretching something, like a metal bar. Stress is the internal force resisting that pull inside the material. It's measured as force over area like pascals or psi.
So the internal fight back.
Exactly. And strain is how much the bar actually deforms or stretches compared to its original length. It's a ratio, so it doesn't have units.
Ah, so stress is the internal cause, strain is the resulting deformation effect, and strain is dimensionless. Got it.
Precisely.
What about heat and work? Both energy transfer, but different how?
Okay, so heat transfer happens because there's a temperature difference. Energy moves from the hotter thing to the colder thing.
Driven by temperature.
Right. Work, though, is energy transferred when a force makes something move, like a piston moving in a cylinder or you pushing a heavy box. Force acting over a distance.
So temperature difference for heat, force, and movement for work. Clear.
Yep. Fundamental distinction.
Let's shift to applied stuff. 4-stroke engines. Can you walk us through the cycle quickly?
Sure. It's a cycle, right? First, intake. Piston moves down, sucks in air and fuel.
Okay.
2nd, compression. Piston moves up, squeezes that mixture, gets it ready.
Right.
3rd, power. Spark plug ignites it, bang. Pushes the piston down hard. That's the useful stroke.
Where the work happens.
Exactly. And 4th, exhaust. Piston comes back up, pushing out the burnt gases. Then it starts all over again. Intake, compression, power, exhaust.
Nice and rhythmic. Okay, and centrifugal pumps. How do they work their magic?
It's pretty clever, actually. You have a spinning part, the impeller. It flings the fluid outwards, making it go faster, increasing its velocity.
That gets it up.
Then, this fast-moving fluid goes into a specially shaped casing of the volute, which widens out. As the area increases, the fluid slows down.
And slowing down does what?
That decrease in velocity gets converted into an increase in pressure. So you trade speed for pressure, which is what you need to move the fluid somewhere.
Speed into pressure. Very neat. Okay, skills time. What about essential software for a fresher?
The basics usually start with AutoCAD for 2D drawings like blueprints, and then something like SolidWorks for 3D modeling is pretty standard now.
2D and 3D design.
Yeah. And familiarity with MATLAB for calculations or basic simulations is a really good thing to have. Even just showing interest in learning more advanced tools like ANSYS for analysis is positive.
So CAD and some simulation knowledge. Makes sense. And GD&T, geometric dimensioning and tolerancing. Sounds complex. Why is it important?
GD&T. It's like the grammar of engineering drawings.
Yeah.
It goes way beyond just saying a hole is like 10 millimeters wide.
How so?
It specifies exactly how round that hole must be, how straight its axis is, where it's located relative to other features, all with specific tolerances. It defines the acceptable wiggle room for form, orientation, location.
To make sure parts actually fit together and work properly.
Precisely. It ensures interchangeability and function. It's absolutely crucial for manufacturing things accurately. The language of precision.
Okay, that clarifies it. Lastly, a quick touch on professionalism, things like being open to relocation or shift work.
Yeah. Interviewers often ask about this. Just showing you're flexible and adaptable is important. It signals commitment to the job and the industry, that you're serious.
Willing to meet the demands of the role.
Right. Okay, so to kind of wrap this up, a good grasp of fundamentals, knowing some practical applications like engines and pumps, plus having those key software skills.
Yeah.
That's the core package.
That's a huge part of it. And crucially, being able to talk about it clearly, to articulate what you know.
Yeah, communication is key. You need both the knowledge and the ability to explain it.
Absolutely.
All right, so here's a final thought for everyone listening, something to maybe chew on. Given these fundamental concepts we've discussed and how fast tech is changing, what do you think are the really big engineering challenges mechanical engineers will be facing in, say, the next 10 years? Something to ponder.
That's a great question to end on. Lots to think about there.
Indeed. Well, thanks for joining us for this deep dive.